It was a momentous second when the Andromeda cloud, for the present, transformed into the Andromeda Galaxy. The James Webb Telescope has seen 6 galaxies that existed a fraction of a billion years after the Big Bang. This is unbelievable when you truly consider the night sky. Looking at a pinpoint of light, when magnified, it gives you one of these incredible images from the James Webb Space Telescope. It was a momentous moment as the Andromeda cloud transitioned into the Andromeda Galaxy. For a long time, our understanding of the Andromeda Galaxy was limited to basic observations. However, with advancements in technology and the introduction of the James Webb Space Telescope, our understanding has grown immensely. Now, things will change, as the James Webb Space Telescope has detected alarming signals coming from the Andromeda Galaxy. These signals have sent shockwaves through the scientific community, leaving astronomers both inspired and curious. But what exactly do these signals mean, and why are they creating such a stir among space experts? Join us as we explore. Just 2 minutes earlier, the James Webb Telescope shut down immediately after detecting disturbing signals from the Andromeda Galaxy. Before this, we could see far beyond our eyes into the universe. Astronomers once believed the Milky Way was the entire universe. This lack of knowledge was primarily due to limited tools for observing distant structures and individual stars. However, everything changed when we discovered the Andromeda Galaxy. It served as our first sign that the universe extends far beyond the Milky Way. In the 17th century, Galileo Galilei's early work with telescopes revealed the true nature of the Milky Way. He observed that it contained numerous stars, challenging the prevailing notion of its singular importance. Everything shifted during the 1920s when Edwin Hubble observed objects beyond the Milky Way using the Hubble telescope. Edwin realized that these bright objects moving through the universe were galaxies distinct from the Milky Way. One of these galaxies was the Andromeda Galaxy, or M31. While this was the first time we observed Andromeda through a telescope, Persian astronomer Abd al-Rahman al-Sufi had documented it in the 10th century. Thanks to technological advancements in the 20th century, astronomers were able to study Andromeda's true nature. It became clear that Andromeda is not just a cloud but a massive galaxy of stars, much like our Milky Way. Our galactic neighbor is approximately 2.5 million light-years from the Milky Way. Since its discovery, our methods of studying Andromeda have significantly evolved. We've progressed from ground-based observations through telescopes to space observatories like Hubble and the James Webb Space Telescope. Each advancement in technology has taken us to new heights, helping us unravel the mysteries of the Andromeda Galaxy. We now have more knowledge about its composition and structure, making Andromeda a benchmark for studying the development of galaxies. Scientists believe that to better understand the universe and the Milky Way, we must focus on the relationship between Andromeda and the Milky Way. This is especially important, as the two galaxies are expected to collide in about 4 billion years. While studies and predictions have advanced, the James Webb Telescope has recently detected a disturbing signal from Andromeda. This unexpected signal has left scientists puzzled, raising questions about its precise origin and potential implications. The telescope's advanced sensors detected unusual activity within Andromeda's core. The signal revealed results that starkly contrast with previous observations, stunning scientists worldwide. The data points to massive processes occurring within the galaxy, potentially linked to its supermassive black hole or previously hidden events. Notably, recent discoveries suggest that Andromeda's mass may be significantly greater than that of the Milky Way, reshaping how we understand both galaxies. The James Webb Telescope has also provided detailed images and spectra of Andromeda, revealing the formation of new stars and their structural arrangements. This new information is crucial for understanding cosmic development and the conditions for life. Furthermore, the telescope's data indicates increased activity in Andromeda's dynamic core, which has influenced its overall environment and is expected to shape its future development. By examining the gravitational effects on stars within Andromeda, scientists gain insights into the distribution of mysterious dark matter throughout the galaxy. This helps us understand its influence on the universe's fundamental workings. Understanding dark matter and its impact on the universe remains one of cosmology's greatest challenges. Recent breakthroughs by the James Webb Telescope have inspired further investigations. As more information becomes available, we are learning about Andromeda's past and future. Research has shown that Andromeda possesses unique characteristics that set it apart from other galaxies. Its sheer size demands attention, with recent estimates suggesting a diameter of approximately 220,000 light-years. This makes it one of the largest galaxies in the local group, significantly larger than the Milky Way. This vast size contributes to its mass, containing around 1 trillion stars, surpassing our galaxy in star count. Research also reveals that Andromeda is not a typical spiral galaxy. It has a bulging core and a dense center surrounded by rings of dust and gas, a fertile ground for ongoing star formation. Such features demonstrate a dynamic galaxy shaped by constant processes. Among its many components, its center stands out. It is characterized by a double nucleus, indicating the presence of a supermassive black hole similar to, but not identical to, the Milky Way's. The Andromeda Galaxy is also surrounded by a halo of stellar debris, including stars, planetary systems, and globular clusters, spanning hundreds of thousands of light-years. This massive envelope tells an enthralling story of the galaxy's turbulent origins and history. With these discoveries, astronomers are one step closer to understanding the critical role of dark matter in galaxy formation and evolution. Yet, questions remain about its enigmatic nature and the part it plays in the dynamics of massive structures. Andromeda also boasts another fascinating feature: its satellite galaxies. Its halo contains over 20 smaller galaxies, some of which are undergoing tidal stripping, losing their stars and gas. This process illustrates the dynamic nature of galactic evolution and how galaxies interact over time. So, what does the future hold for the Andromeda Galaxy? Its shape and trajectory captivate astronomers and those seeking to understand the universe. The possibility of it transitioning from a spiral galaxy to a ring galaxy is central to its evolution. Studies suggest that Andromeda has likely experienced numerous interactions with other galaxies throughout its history. Ultimately, Andromeda's future hinges on its inevitable collision with the Milky Way, predicted to occur 4 billion years from now. The outcome of this collision will be the formation of a new galaxy from these two colossal entities. While this is a part of cosmic evolution, the vast distances between stars mean that the collision won't be an immediate, catastrophic event. After the collision, the two galaxies will merge, creating a new structure. The interaction of their gases and dust will ignite new rounds of star formation, producing a spectacular celestial display. Ultimately, this event will result in the formation of a single elliptical galaxy. Such collisions are not uncommon in the universe but are significant milestones for our understanding of galactic evolution. The anticipated collision of the supermassive black holes at the centers of the two galaxies adds complexity to this cosmic event. This interaction will likely emit vast amounts of energy, providing valuable insights into the nature of black holes and their role in shaping galaxies. The merging of the Milky Way and Andromeda will not only reshape their individual structures but will also redefine our understanding of galactic evolution. This collision, while dramatic, is part of a natural cycle in the universe, where galaxies interact, merge, and form new entities over billions of years. Following the merger, the newly formed galaxy, often referred to as Milkomeda by scientists, will likely become an elliptical galaxy. Its structure will differ significantly from the spiral forms of the Milky Way and Andromeda. This transformation will mark the culmination of a series of complex gravitational interactions, including the redistribution of stars, gases, and other cosmic material. The fate of our solar system during this event is uncertain. While the vast distances between stars make direct collisions unlikely, the gravitational forces at play could potentially displace the solar system. Some models suggest it may be flung into a different region of the galaxy, or perhaps ejected into intergalactic space. The collision will also provide an unprecedented opportunity to study the behavior of supermassive black holes. When the black holes at the centers of the Milky Way and Andromeda merge, they will release powerful gravitational waves, rippling through spacetime. These waves could offer new insights into the nature of gravity and the early stages of the universe. Beyond the physical consequences of the collision, this event holds significant implications for our understanding of cosmic timelines. The merger highlights the continuous and dynamic nature of the universe, where no structure remains static forever. It also emphasizes the interconnectedness of galaxies, demonstrating how their interactions shape the broader cosmos. Implications for future exploration. The discoveries made by the James Webb Space Telescope regarding Andromeda's current state and its future interactions with the Milky Way are just the beginning. As technology continues to advance, astronomers will likely uncover even more about the intricate processes driving galaxy formation, evolution, and interaction. New generation observatories, such as the Nancy Grace Roman Space Telescope and ground-based instruments like the Extremely Large Telescope, ELT, will complement the James Webb Telescope's findings. These tools will provide more detailed observations, allowing scientists to map the gravitational influences, star formation regions, and dark matter distribution within Andromeda and other galaxies. Such studies will also deepen our understanding of the universe's large-scale structure, offering clues about its origins and ultimate fate. By unraveling the mysteries of galaxies like Andromeda, we are not only learning about our cosmic neighborhood but also about the fundamental forces that govern the cosmos itself. A look at Andromeda's role in cosmic evolution. The Andromeda Galaxy is more than just a neighboring giant. It serves as a critical point of reference in understanding the life cycle of galaxies. Its proximity to the Milky Way makes it an ideal candidate for in-depth studies, providing insights into how galaxies form, grow, and interact over time. Andromeda's vast structure, with its trillion stars, countless planetary systems, and active core, offers a living laboratory for astronomers. By examining its features, such as its spiral arms, dense nucleus, and extended halo, scientists can test theories about galaxy formation and evolution. One key area of interest is the behavior of Andromeda's supermassive black hole. Positioned at its core, this enigmatic object influences the galaxy's dynamics, from star formation to the distribution of matter. Recent observations suggest heightened activity in this region, possibly triggered by interactions with smaller satellite galaxies or an influx of material into the core. This activity aligns with findings that galaxies with active cores, or active galactic nuclei, AGN, play a significant role in shaping their environments. AGNs can drive powerful winds and jets of energy, influencing star formation rates and the movement of interstellar gas. Understanding these processes in Andromeda may provide clues about the development of other galaxies across the universe. The cosmic collision. More than just destruction. The eventual collision between the Milky Way and Andromeda is not merely a destructive event, it's also a creative process. The merging of these two massive galaxies will lead to the redistribution of their stars and gas, sparking new rounds of star formation. These young, luminous stars will illuminate the newly formed galaxy, marking the beginning of a new chapter in its history. While this process unfolds over billions of years, the impact on smaller satellite galaxies will be more immediate. These smaller galaxies, many of which orbit Andromeda or the Milky Way, may be drawn into the collision, either merging with the larger structure or being torn apart by tidal forces. This cascade of interactions will contribute to the dynamic reshaping of the local galactic group. The study of such collisions, both in simulations and through observations of other merging galaxies, suggests that the eventual result will be a single elliptical galaxy with a smooth, featureless appearance. This transformation will reflect the culmination of countless gravitational interactions, from the initial approach to the final coalescence of the two cores. Broader implications for understanding the universe. The exploration of Andromeda, both in its current state and its future trajectory, has far-reaching implications for our understanding of the universe. It challenges us to consider the